So we have 3 SMA lines, and we want to get a signal only when they match in direction. So if this guy is sloping up, and this guy is sloping up, and this guy is sloping up, only then do we get a long signal, and then wait until they're all sloping down before we start getting a short signal, somewhere around here. Now that's pretty easy. We can just use an AND node and say, hey, give me a signal when all 3 are sloping up or down. So we'll plug them in, and as we plug them into the AND node, we're getting fewer signals because the AND node is saying require that this and this and this are all producing the same signal on the same bar. And so only on the bars in which they're all going down do we get a short, and then on the ones where they're mixed, we get nothing, right? So if we go, for example, over here, we're getting long because they're all sloping up. And then as soon as the faster one starts sloping down, that 14 period one, we lose our signals because they're mixed. This guy and this guy and this guy are not matching. We've got short, long, long, so we get nothing. But what if we want to be a little more flexible with that? We say, you know what, I don't want to be that rigid. I just want 2 of the 3 to be giving me a signal, and that's good enough. So if this and this are moving up, that's okay. Let's still get a long signal even if this guy started going down. That is actually pretty easy with the additive node. So let's go over here, add the additive node to the board, and we'll bring those same slope solvers onto the board and connect them. Now, when we first connect them, we're going to get some weird signals because what this additive node is doing is adding up the values from all of them. Actually, we should take a quick step back and discuss what I mean by the outputs. What are we adding up in the first place? So remember, these signals are not just on or off, or long or short. They actually have a value from 0 to 1. So if we look down here in the Bloodhound panel down here, the long side has a value between 0 and 1. So you can see these long signals have a value of 1, and then and a 0 for the short because there's no short output. And then over here we have the opposite. We have 0 for long and 1 for short. It says -1. That just lets us show it in a nice way, but just think of it from 0 to 1. And so 1 is 100% output. But in order to give each of these rules a weight, because that's what we're doing, we're saying, hey, I want to weigh each of these as a partial value, and only once we reach a certain weight of values do we want an actual signal like this. And so what we can do is say, I want each of these guys to give me a partial value. Instead of being 1, 1, and 1, we could do, let's say 0.4, for example. 0.4, and then 0.4, and 0.4. And by the way, I'm getting there by clicking on one of the slope solvers and going to the options menu at the top. That allows us to set a weight of a multiple of less than 1. Okay, so by doing that, now remember, I'm just looking at one of these. I'm looking at the SMA 14 period. So as this SMA 14 period is sloping up, we can see we're getting output down here, but we're no longer getting signals, these full racing stripes, because you'll see that we're now getting a long confidence. I'm sliding around here. We're getting a long confidence of 0.4. That's what we said. We said, hey, when we get a full value from this guy, its max value is 0.4, right? And so that's not enough to reach a signal. But take one look here, we can see there's this line here that is the confidence threshold. You can see it's at 0.8. That's the default value in which once we've reached above 0.8, at least 0.8, that counts as a full signal. So if I have this guy giving us a 0.4 or 40% of a signal, and I have this guy giving us a 0.4 on the same bar, let's go ahead and disconnect that, set that aside for a second. Once we get 2 of these guys, only on those bars in which they both are giving me a signal, a value, an output of 0.4, then we've reached that threshold of 0.4. See that line there, or I'm sorry, 0.8, that line there. And only once we reach that do we start getting these racing stripes. And so now if we bring this guy in, it's also got a value of 0.4. If I plug that into the additive node, we're basically saying only give me a signal when at least 2 of these 3 solvers is outputting a value, right? So we can see on this bar right here, we got 0.8 from the long, because that's 2 of them were giving 0.4 each, so 0.4, 0.4, and that was enough to be a long signal. And then 1 of them is giving us a short output of 0.4, so it wasn't enough to be a short signal. And just like we saw over here, as this guy started to go down, actually it looks like we didn't even get a signal on this one, because I'm guessing the big one down here did not change. So if we do SMA, yep, so we can see that guy did not change from one bar to the next, and so we didn't get at least 2. One was long, one was short, but there was no output. But we can see once that started to turn, we got short from this guy and short from this guy, and so we started to get short, short, enough for a signal. And over here, long, long, enough for a signal. Now you might be wondering, why is 0.8 the threshold? It's a little arbitrary. It gives you a little wiggle room, but you can change that by going into the indicator settings for Bloodhound. When you add it to the chart, we can see long threshold and short threshold. So you even have control. You can say, you know what, I want my longs to be 0.8, but I want to be even more strict with my shorts. I need all 3 of them to be going down before getting a short signal. So by applying, we're going to get fewer short signals. Right? So we're still getting the same outputs of 0.8, but that's not enough to reach a full signal. We need all 3 shorts in order to get a full signal. So this was just a simple example of using the additive node. Remember, we are setting the individual weights in the individual solvers. So when I plug this in, it's not the additive node that's deciding that. What's deciding it is the output coming from the individual solver. So we go to the solver, options, there's our multiply output, and we're saying the max value from this guy is 40%, and if we reach 80% by default, anything above that, we're going to allow a signal to come through, either for information on the chart or using these as an automated trade signal in Blackbird. So we can say wait until 2 of them have reached their value, and only then do we trigger a trade automatically. And you could imagine a scenario where you say, you know what, we could have a bunch of these and say, let's have the bar direction be a very high weight. So let's give it like 0.6, right? And then each of these 0.2, actually, you know what, let's make it 0.3, 0.3, 0.3, 0.3. So the idea here in this example would be these 3 right here, if all of them are giving us a long output, then that's enough to count as a signal. But this bar direction is much higher weight. It's more important. So we're saying the bar direction, it's a 0.6. So we can combine this bar direction with any one of these, and that would be enough for a full signal, for a 0.8 threshold, for reaching our threshold for a signal. So this and 1 or all 3 of these. Either one could meet our criteria. So you can imagine a scenario where you have one rule that has a stronger weight than the others, but if you have enough of the others, that would also be enough to produce a signal. So this was just meant to be a simple example. Let us know down in the comments below if this made sense, and if there's any other simple topics like this that you'd like to see, or if you'd like to dive deeper into the additive node or more examples with it.